Okay, students, coming to the next concept, intensity of electric field due to uniformly charged ring. So, uniformly charged, it is not point charge. Charge is continuously present on the surface. Consider a uniformly charged ring means a charge resides only on the surface. Total charge on the surface is Q. So, radius of the charged ring is nothing but R. Now I am considering a point P which is at a distance x from the center. At this point P, what is the electric field given by this continuously charged ring? So for this, remember, in case of this continuously charged bodies, so we cannot able to apply point charge formula 1 by 4 pi epsilon naught q by r square directly. First of all, consider a small element, charge element. So its length is dl, amount of charge is dq. So it is giving electric field at this point P. You know very well, if it is positive charge, electric field due to positive charge is away from it. Here I am considering dq charge, so it gives electric field dE. And similarly, niche bottom also I am considering one more point charge element dq. It is also giving electric field dE. And here at this point P, so with this horizontal line, dE makes an angle theta. Imagine it makes an angle theta. dE, it is also makes an angle theta. Then electric field is vector making an angle theta. So resolve this vector into two components. Along this direction you will get a cos component dE cos theta. Perpendicular you will get a sin component dE sin theta. Similarly dE here also, which is given by this lower point, same angle theta, dE cos theta, dE sin theta. dE sin theta terms are equal and opposite cancel. So dE cos theta are in same direction. So at this point P, total electric field is given by the cos components. Try to understand this diagram. Now the important point is, what is the electric field given by this point charge, means by this element dq, what is the value of dE? So here the distance is x, here the radius is r. This distance becomes root of r square plus x square. Apply Pythagoras theorem, you will get root of r square plus x square. Now what is the value of dE? So again apply the electric field due to point charge model 1 by 4 pi epsilon naught. Charge is dq, distance is nothing but root of r square plus x square. So dq by root of r square plus x square whole square. So root square cancel, this is the value. Now, sir, what is the value of this dq? That is the sentence. I told you the length of this element is dl. So, and total charge on this surface is q. Total charge means a total circumference is nothing but 2 pi r. For 2 pi r circumference, total charge is q. But I am not considering total circumference, I am considering only this much length dl. So for dl length, I am considering the charge is dq. So this sentence you have to understand how I got this sentence. Cross multiplication of these two divided by this value. So small amount of charge dq is equal to q. These two you can multiply, q into dl divided by 2 pi r. So this is the amount of charge dq on this surface. dq value will be like this. Substitute this dq in this formula. Okay na? Now net electric field is given. Net electric field at this point P is, as I told you, cos components are giving electric field. So dE cos theta, dE cos theta, dE cos theta, so many components are there. So net electric field is nothing but sum of all these terms. So sum of similar terms, small terms is nothing but integration. So net electric field at point P, E is nothing but integral dE cos theta. dE value already I told you is the dE value. dE value is like this, and substitute this dE value cos theta. Here dq already I told you dq value. Substitute this dq value here. dq you can substitute cos theta. What is this cos theta, sir? Again coming to the diagram. So here vertex opposite angles are equal. Here angle theta, here also angle becomes theta. Here angle theta, here also angle becomes theta. Consider this triangle, right angle triangle, you will understand very easily. Cos theta is nothing but adjacent side divided by hypotenuse. adjacent side is nothing but x, distance x, hypotenuse is nothing but root of r square plus x square. This cos theta value is nothing but x by square root of r square plus x square. So see here, bring all the constant terms outside, only integral dl is remaining. So all are constants I brought outside, only integral dl is remaining. Now integral dl is nothing but, I told you in the diagram, this is the small portion dl, small portion dl, small portion dl, total integration of dl is nothing but total circumference. Total circumference is nothing but 2 pi r again. So this 2 pi r and this 2 pi r will cancel. Now, so remaining terms are nothing but 1 by 4 pi epsilon naught qx by, sir, what is this r square plus x square whole power 3 by 2? How you got these two, sir? Check it. So this is root of r square plus x square, and another one is root r square plus x square. So this is power 1, this is power 1 by 2. So you will get r square plus x square whole power 1 plus 1 by 2 is nothing but 3 by 2. So this is the value I am writing here. So this is the electric field given by uniformly charged ring at a distance x on its axis. At a distance x on its axis. On its axis, electric field is, this is the value, 1 by 4 pi epsilon naught qx by r square plus x square whole power 3 by 2. Suppose the point P is at the center. That means I am considering this P is at center. So P is at center, that means x becomes 0. So again in this formula, substitute x equal to 0, automatically 0 into something is nothing but 0. Check it, 0 is there, automatically electric field becomes 0. That means electric field at the center of charged circular ring, electric field at the center of charged circular ring becomes 0. On the axis only you will get electric field. Suppose if it is positive charge, electric field is away from it. If it is negative charge, electric field is towards it. But at the center, electric field becomes 0. So remember, so this is the electric field due to uniformly charged ring. So we will see the next concept in the next slide. Thank you.